Let's say you have a friend who lives really far away and you can only observe their facial expressions and tell whether they're happy or sad. You don't know the weather at their place. So you design this experiment kind of where the observations are your friend's moods and the hidden states are the weather conditions. So the observations are whether the person is sad or happy, and the hidden states are whether it is raining, whether it is cloudy, or whether it is sunny. So the model is saying maybe I cannot directly know the weather, but by knowing whether the person is sad or happy, I can guess whether the weather what the weather might have been. So let's take a look at all the green arrows first. So these green arrows show the transition probabilities. That means if the weather is, okay, for example, if the weather is rainy today, what is the probability? So if the weather is one thing today, what is the probability of the weather being some other thing tomorrow? Okay, so for example, if today is rainy, there is 0.5% probability that it still remains rainy. There is 0.3 probability, okay, that it becomes cloudy, and there is 0.2 probability that it becomes sunny. And if you take the sum of all these probabilities, so for rainy to rainy, these are all called as transition probabilities. These are in green. So these are transition probabilities. So rainy to rainy is 0.5, rainy to cloudy is 0.3, and rainy to sunny is 0.2. And their total sum should always be equal to 1. Okay, because it makes sense, there is no other fourth weather condition, so either it will stay rainy or it will become cloudy or it will become sunny. Total probability should be 1. Similarly, if you consider all the green arrows from cloudy, so cloudy stays cloudy with 0.2 probability, cloudy becomes rainy with 0.4 probability, and cloudy becomes sunny with 0.4 probability. So their sum is 1. Similarly, if we have sunny, sunny stays sunny with 0.7 probability, sunny becomes cloudy with 0.3 probability, okay, and there is no direct arrow from sunny to rainy here, so we will treat that probability as 0. Basically, sunny to rainy cannot directly happen, it will have to go via cloudy, so that probability is 0 and total sum will be 1. Okay, so this entire green part, the part that is formed with the transition probabilities, this is called as a Markov chain. This is called as a Markov chain. Okay, what is the Markov principle or Markov assumption? Is that the next state depends only on the current state. The next state depends only on the current state and not on the full past history. So tomorrow's weather depends only on today's weather. Tomorrow's weather depends only on today's weather.